This is the second lecture of strength of materials or mechanics of solids. In this second lecture, we will continue our main topics. We will enter into the first unit according to JNTU syllabus. We have started discussion regarding stress and strain. Stress is the resistance force that is acting, that is induced within the body when the forces are acting on it. The resistance forces offered by a body against the deformation. The term we should remember is against deformation. It is sigma is equals to P by A. It is load, resistance load for the area. This area is perpendicular to this load, applied load. Strain is the ratio of change of dimensions of the body to the original dimensions is known as strain, or the ratio of change of length to original length of a member. So that is strain. Now, coming to the types of strains, the types of stresses and strains. We have got different types. Stresses, two are there. One is normal stress, shear stress. In normal stress, we get compressive as well as tensile. In strains, we have different again. It goes again with whether it is the load, the applied load is normal or tangential. Based on that, the strain is also divided. So it can be a shear strain or a primary strain. Instead of normal, we use normal stress, and the second one is primary strain and shear stress, and here it is shear strain. See here, here he speaks only with respect to the normal stresses. The normal stresses may be they are tensile stresses or compressive stresses. So what is a tensile stress? When the loads that are acting along the axis, when the loads are acting along the axis of a body or perpendicular to the cross section of a body, when the bar is stretched by a force P, the stresses are tensile stresses. It's a, because of that load, we will find a stretching force. The body experiences a stretch. So that is tensile stress. And if the body experiences a compression, and the stresses, the resistance forces induced within the body for on the application of compressive loads, and the stresses induced are compressive stresses. That is compressive stresses. Next, strain. Tensile strain. If the applied load is tensile load, then the strain induced is tensile strain, and if the applied load is compressive, then it is compressive strain. Now, there is one more term, volumetric strain, a very important one. Because of an application of a load, definitely we will find the changes in dimensions of all the dimensions of the body. If it is a cuboid and the body is subjected to uniaxial load, it leads to the changes in dimensions in all directions: x-axis, y-axis, z-axis, length, breadth, and height. If so, this change in volume to original volume is the volumetric strain. Change in volume because of the load, the dimensions are getting changed. When all dimensions are changing, finally the volume will also change. when the body is subject to, and the loads are within the elastic limit, and the change in the volume to original volume is the volumetric strain. Shear stress. First one, that is normal stress we have seen. Now it is shear stress. Shear stress act in a direction parallel or to the surface area are called as shear stresses. It is parallel to the surface area. See, either it should be parallel or it should have some eccentricity. So instead of acting like along this axis, it should have an eccentric P here, one P here, another P here. So because of these two, it will experience a crushing or shearing. We call it as shearing. Shearing force it experiences, and the stresses induced because of this is shear stress. And shear stress is given as shear resistance by shear area. Here we have one example. So that example is this. Either the load can act tangentially or parallel to the axis or acting over a surface, and the loads can be like this also. It leads to shearing off. So here what he says is stresses act in a direction parallel to the surface are called as shear stresses. Stresses act in the direction parallel to the surface area are called shear stresses. Now here we have two metallic sheets. These two are fastened. They are joined together by using a rivet. We have a rivet here, and one load P is in left direction, other one is in right direction. Both the magnitudes are same. Say for example, magnitudes can be same or it can be different also. Here, right now, here the loads, these forces that are acting are same magnitude. Say now, what happens here? Shearing takes place. Here, it will cut off like this. If this P goes on increasing, it increases above its ultimate strength, then it will start shearing, cutting off. It will be subjected to deformation. So that is what shown here. So if this is axis, and because of this P, you have a P this side, and here we have P this side to the left. So one is from the, here it is shown, actually it is from left and right. So here it is shown top and bottom. So you have an eccentricity, is the distance between axis and the line of action of this force. This is eccentricity. So when this is there, so you will get, it will experience, the member will experience a shear stress, and this shear stress is given by shear resistance by shear area. So P by A. So after shearing off, whatever the area is there, that is considered as shear area. Now shear strain, shear stress over next step, shear strain. Suppose you are having a body, initially you are having a body like this, a rectangular body, and this body is subjected to a load P over one surface. So it is parallel to the surface, it is acting over the surface. So what happens? You will find the dislocation or displacement of this top surface from its original position to a point which covers a distance, a change in length del. So here you find a change in length is del. Initially it was its position is here, but after application of the load, it got changed its position. So it is In case of tangential, this happens in the case of tangential force on the forces that are acting uh, over the surface. Same, the shear stress condition is considered here. When it is subjected to, when the load is subjected to the shear loads or over the tangent over the surfaces or acting tangential, then it is the change in positions will lead to, we call it as shear strain, and what distance it moved, it is del. So del divided by its original length is L. So that is shear strain. So this is L, and when it is moving to the right side, it will experience a change. There is a change in this length. So that change here, they consider it as this del. So del by L will give us shear strain. So this is shear strain. So this del divided by this length L. This is the length L. So you won't find the change in dimension. This dimension will not change, but it changed its position, but the dimension that is changing is this one. So say this is L. So the change in dimension L is considered to be this del. So this del by L is the shear strain. Now, again, regarding strains, primary, direct, linear, or longitudinal strain. So, what is this? It is nothing but when the applied load is normal, the type of strain induced, the type of strain that is taking place over the body, or changes in the dimension that are taking place, are called as longitudinal strain, primary strain, direct strain, or linear strain. And shear strain is because of the shear forces, and this longitudinal strain is because of normal stresses, normal force. So you are having a body here, a member. This member is subjected to a load, and you will find changes in the dimension, changes in the length. L got changed to an extension del L because of pulling force. It is experiencing a pulling force, or it can be a compressive force also. Instead of in this direction, the direction may be a compressive direction. So the change in the length is del L, and original length is L. So this is a longitudinal strain. Whereas this shear strain is, the applied load is shear loads. Shear load means the loads which are parallel to the axis or tangential, parallel to the surface, or acting over the surface, they are shear strains. So shearing takes place. You have a body here, so we are applying some force. So because of this force, shear, some a deformation takes place. So that deformation leads to, if it is within the elastic limits, and the change in the dimension by its original dimension is considered to be a shear strain. Secondary or lateral strain. So strains have got different understandings. Here, this lateral strain means, consider where a body is subjected to only one normal load, a tensile load. The change in dimensions, all the dimensions will change. The dimensions along the axis, dimensions perpendicular to the axis or parallel to the axis will also change. The change in dimensions perpendicular to the direction of application of the force of the body on the body is called as secondary strain or lateral strain. See, the application of this tensile load increases this length but decreases the breadth and depth. These cross-sectional dimensions are decreasing. So the change in this cross-sectional dimensions will speak regarding secondary or lateral strain. First one is primary strain, the second one is lateral strain. If the dimensions are changing in the direction of the application of the load, it is primary. Or if the dimensions are changing perpendicular to the applied load, it is lateral strain. So that is what is discussed here, a lateral strain, that is secondary strain or lateral strain. The change in dimension is perpendicular to the direction of applied force applied, and it is a ratio of change in breadth or width to original breadth or width. So lateral strain, del V by D or del D by D. One note is given here. If linear strain is tensile, lateral strain is compressive, and vice versa. If linear or primary strain is tensile, tensile means primary strain is tensile, the lateral strain, the change in dimensions, the cross section, the lateral strain is compressive. The dimensions are decreasing. If in one direction dimensions are increasing, in other direction the dimensions will decrease. So that's why if the applied load is a tensile load, the strain induced is primary strain in the direction of the load, in other direction it is compressive. If it is a compressive load applied, then the changes in other dimension are tensile. And we have a relation between this lateral strain and longitudinal strain, secondary strain to primary strain. The ratio of secondary strain to primary strain is termed as Poisson's ratio mu, or 1 by m. This mu is also equal to 1 by m. It is a transverse or lateral strain divided by linear strain. All the names can be used: primary, linear, longitudinal, or direct strain. This is transverse, secondary, or lateral strain. So this is negative. Why it is negative? Because this Ex and Ey are both opposite. If one is increasing, other one is decreasing. So this negative sign it says that as lateral strain is always opposite to linear strain, or linear strain is always opposite to lateral strain. That is the reason why we get a negative sign here. The theory of isotropic elastic and the Poisson's ratios is in the range from -1 to half. Here some values were given for values of Poisson's ratio of a material in everyday use are given below. Some different materials are here. You have steel, cast iron, copper, brass, aluminum, concrete, and rubber. For rubber, you have highest values. The changes in the the change in the lateral strain, lateral dimensions, and lateral strain is high compared with the longitudinal strain. So that's why this fraction is more, 0.50. Whereas for steel, linear strain is more, but lateral strains are they're not comparatively, they are very less. We have stress strain relations, Hooke's law. The Hooke's law states that when a material is loaded within elastic limit, the stress is directly proportional to strain. When a body is subjected to uniaxial load, a single load, the load which is parallel to any one of the axes and perpendicular to the plane, plane formed by the other two axes. So that is uniaxial load. When a body is subjected to uniaxial load, and for the type of materials or maybe ductile materials, within elastic limits or about to reach the proportional limit, proportional point, we call it as a Hooke's law, where stress is directly proportional to strain. Here, stress is proportional to strain. That is sigma proportional to strain. This means the ratio of stress to strain is a constant within elastic limit. Say this proportionality constant, when we remove this proportional, we get a constant, that is modulus of elasticity, or Young's modulus. We call it as Young's modulus. Some note is given here. For mild steel, the Hooke's law holds good up to proportionality limit, which is very close to elastic limit, valid for uniaxial loads only. It is valid for only uniaxial loads. And modulus of rigidity, it is from the same relation. Stress is proportional to strain, and this proportionality is removed with substituted with constant is, that is E. Modulus of elasticity is E, or Young's modulus. It is equal to tensile or compressive stress by tensile or compressive strain. So, and the load is uniaxial load. The applied load is uniaxial load. Under that condition only, modulus of elasticity is tensile or compressive by tensile or compressive strain, sigma by E epsilon. So stress is P by A, epsilon, that is Young's modulus, is del L by L. So PL by A del is the expression. Some values were given here. For steel, let us serial number, it is material modulus of elasticity E in gigapascal, giganewton per meter square, or kilonewton per mm square. Giga means 10 power 9. So when it is Newton per mm square, 10 power 9 into 10 power minus 6. So both cancel and it will be kilonewton per mm square. For steel, it is 200 is very high for steel. For wrought iron, 190 to 200. Here it is 20, 200 to 220. For cast iron, 100 to 160. Copper, 90 to 110. Brass, 80 to 90. And aluminium, 60 to 80. Timber, it is 10. It means Young's modulus or modulus of elasticity is E is equals to 200. What does it mean? Stress is very, very high compared with that of strain. So the resistance forces that are induced in the bodies are very, very high. It means it has got very good strength. Steel has got good strength. for not to get deformed. And next it follows, it is followed by wrought iron, cast iron, copper, brass, aluminum, and timber. Thank you. And we will continue this session in the next lecture.